Hello everyone, this is Awab Akib and today we'll be discussing all of pseudocode under the series of Zero to Hero. So if you're somebody who is struggling with pseudocode or who has no idea about pseudocode or who just wants to recap pseudocode, then this is the right video for you. It will be a bit lengthy one. It will be quite exhaustive as we'll be covering everything in this. This would be the basic outline. So we'll start with the very basic concepts. Then we'll talk about the frequently tested questions. We'll have some idea about planning the programs, then some advanced concepts, and obviously some practice questions along the way. This is the whole list of contents that we'll be looking at and the 4 official documents that I'll be using. So we have the A-level pseudocode guide here. All of the documents that I'll be using are already on the drive folder that is shared in the description and in the comment. So this is the pseudocode guide, then this is the syllabus, and similarly for O-level I also have the pseudocode guide and I have the syllabus. Let's start. All right, first of all, in the first topic we have data types. So there are several data types that all of you must be aware of. We have string is a sequence of characters, and they are in the exam you actually have to write the definition sometime as well, so you need to know the exact keywords and the definitions. So strings are sequence of characters, any set of alphanumeric or special characters, and they're always enclosed in quotation marks. So an example of this could be something like this: comsci true 1 2 3 abc. Then we have char is a single character and it is always contained inside single quotation marks like this. Then we have integers, they are whole numbers, so something like 1 minus 5 0, they are negative or positive. Then we have real numbers, they are the values that have a fractional or a decimal part, something like this, so positive or negative numbers with decimals in them. Then we have the boolean values, which could only be either true or false, so there are only 2 values here. And then we have date, we use it to store date time, and the standard format is usually dd, YYY, and this is also written in the syllabus. All right. Then the next thing we'll be looking at is how do we name identifiers. So what is an identifier? As per the syllabus and the pseudocode guide, identifier is the name of a variable, constant, or a data structure like 1D array, 2D array, stacks, queues, and linked list. So a variable is a data container or a named memory location which we use to store data, and the value can be reassigned. So some daily life examples like score, like your kills in a game, like time, like health. And the constants would be that is basically the same thing as a variable, a data container with named memory location to store data and its value, which cannot be reassigned. So this is the only difference. So as the name suggests, you are going to use a constant and the value must not change. Like maybe you have a total opponent count in the game, like maybe you have a damage of a weapon which remains constant no matter how many times you use it in the game. All right, so then we talk about the declarations. So in declaration, this is the general format. You are given this again in the pseudocode guide, so you have to write declare, then the name of the identifier, then colon, and then type. If you do not write it the exact way, then you are at the risk of losing marks. So this should be written exactly. Although the claim is generally that syntax is not checked strictly, but that is not necessarily true. Sometimes syntax also becomes an issue where you can actually end up losing marks. So maybe let's have declare username, that could be string, and then maybe we can have health, that could be real. And then if you want to have a constant here, so these are the variables. These are the variables. If you want to declare a constant, then you just write constant and then you write the name and then you just assign the value directly. For some reason, this is how we are supposed to do it in the syllabus. Otherwise, constants and variables are generally declared the same way in most of the programming languages, except with a few syntax differences. All right, then the next thing we have is the assignment operator. So please remember that assignment operator, so arrow must not be confused with equal. So if you use an equal sign to assign a value, you get a 0 mark. This means that 12 is being assigned to kills. All right, then chord 1 to 3 is being assigned to uname, so on and so forth. Then we have initialization. So the idea of initialization is that you have to give an initial value to something, to some variable, to some value. Maybe let's change it and maybe let's have the score equal to 0 as well. So when you're playing some games, usually the health starts at 100. So this would be your initial value, and then total would start at 0 and score could also start from 0. That again depends on the context of the question. You can't assume that total will automatically or by default start from 0. All right, so until and unless you don't write this line in the paper or score to 0, health to 0, you do not get a mark. There is a separate mark associated with initialization of counters and totaling variables. All right, then we have the input output. So in the input output component, what we do is we have to ask the user to input something, maybe their favorite song, and then we have to output it on the screen. So the song name should be a string because it will be a string of characters, so we declared that. Then we output and then we input. Okay, this is very important. You must always show appropriate message on screen. So imagine that you're playing a game and then the game doesn't tell you anything. So you won't be able to figure it out. You won't know what to write, what to do. Same thing happens in programs. You must always tell the user what they have to do. So you must output an appropriate and a descriptive message on the screen, and then you can take input. Also, it's totally fine if you wrap this in brackets. It won't cause any issue like this. So if the user inputs any favorite song, let's say in the end, and then they input in the end in song name. So this would output as your song name is whatever the value in the variable was. So this would actually output your favorite song is in the end. And maybe we can do some Python side by side, although Python is not part of the syllabus, but just to show you. So we have song or s name, and then I say print your favorite song is s name. So if I print it, it says your favorite song is in the end. So I just wanted to show you one thing here, that quotation marks are not printed, right? Because we are using quotation marks to define that this is a string. So you will not end up outputting the quotation marks, otherwise again it will lead to credit loss. Okay, now we're at the second part. The next thing we have to look here is the operators. So there are multiple types of operators in your syllabus. First of all, we have the arithmetic operator, then we have the relational comparison operators, then we have the logical operators. So what are they and what do they do and how do we figure them out? So first of all, we'll look at arithmetic operators. Arithmetic operators, you all should be well aware of them. Simple mathematics, plus, minus, multiply, divide. Please remember you cannot use an X in computer science. That again would lead to 0 marks. This must be an asterisk sign, okay, not a cross. Then the next thing we have is the raised to power of. So if you want to have some sort of exponent, so you can use this operator. And then the next two things we have are called mod and div. Mod and div are library routines, basically. We'll cover them in detail as well. So they are library routines. That means they are part of the programming language. Since we're using pseudocode, so they're part of the pseudocode syntax, and we can directly import them from the language. We don't have to write their functionality. What does mod do? Mod returns the remainder of v1 divided by v2. So this is also a past paper question where they asked you to define what each of them are and how do they differ from each other. Okay, and you have to give an example. So mod will always return the remainder of v1 divided by v2. Let's say you divide 10 by 2, so the remainder would be 0 and quotient would be 5. So that's the idea. So this remainder is from the mod and then the quotient is from the div. So for mod we'll write 10 comma 2 and we get 0 as the output. Then div returns the quotient of v1 divided by v2 without the fraction part. Okay, so without is the keyword here. I'll just highlight this, which means if I say div 10 comma 2, so it returns me 5 as quotient, and then if I say 11 comma 2, so that also gives me 5, and in this case the remainder would be 1. So 2 times 5 is 10, 11 minus 10 is 1. So this would be the quotient, the answer of div, and this would be the remainder, which would be the answer of module. This is what we use in order to figure out if a value is even or odd. Okay, then the next thing we have is the relational and comparison operators. So relational and comparison operator includes greater than equal to, less than or equal to, and not equal to. So this is the sign in pseudocode. Please do not confuse it with the Python symbol, that is this one. If you use it again, you lose marks. Then we have the logical operators and or not. So we use and when we want all the conditions to be true at the same time. Like let's say you want to check if value is greater than equal to 90 and value is less than equal to 100. We use or when there at least one condition is true. So maybe when you want to check, let's say if value is less than 0 or value is greater than 100, then this should output an error. And not we used to convert the current boolean value into the opposite one. So when we say not true, it becomes false, and when we say not false, it becomes true. And then lastly we have the and% here, which is used to concatenate or join strings. So when I say hello and I have world, and if I want to make a new string and I want to output it, so I can just put the and% between them and this will output hello world. Okay, now we move on to the third topic, which is constraints. Okay, so when we talk about programming constraints, we have these three as part of our syllabus. We have sequence, selection, iteration. And before that, we need to understand that all the problems that we look at can be eventually decomposed into smaller parts, which would be input, process, output, and storage. So let's say that you are making a game, maybe some racing game. So in the racing game, there would be some inputs, there would be some processes like the graphics, like the code that you'll write, and then there would be some output that the user would be able to play. User would be able to interact with the controls and the characters in the game, and then there would be some storage where you can maybe save some game progress, auto save, etc. Okay, so we have the programming constructs now. We have, first of all, we'll talk about sequence, then selection, then iteration. So what is sequence? Sequence executes the code line by line in a sequential manner. So this is the first concept. The idea is that I'll just highlight these. We execute the code line by line in a sequential manner. That means if I have multiple print statements here, print A, print B, and print C, if I have these, so they'll be printed line by line. This is sequence. Then in selection, the idea is that we select one of the multiple conditions and paths in a program, and we use if conditions and case of otherwise for it. So we'll talk about this in detail. Then we have iteration. Iteration means repeating a block of code, and there are two types of iterations. One is conditional and one is count controlled or iterative. And within conditional, we have further two types of loops, which are preconditional loop and post-conditional loop. And then again, we'll talk about this. Okay, now we are looking at topic 4, which is selection. So as we talked about, selection is applied when one of the multiple conditions is chosen in multiple paths from the program. So some examples, let's say you're playing FIFA. So you have all these buttons that you can press. So maybe let's open a controller here. So at any given point in time, you can press any of these buttons and then they will end up doing some sort of action on the screen depending on the game. So you can either press rectangle, triangle, or you can press multiple buttons. Similarly, if you have a calculator in front of you, so you can also press multiple buttons on the calculator and then it will also perform an action. So that is the idea. Basically, we want to choose one of the multiple options available in our program. So this is where selection comes in. And then selection is done using two constructs. We have if else if statements, and then we have the case of otherwise. They are both very important and we'll be looking at both of them. So first of all, here we have an if condition. This is the exact syntax of if condition. You will see in the pseudocode guide that there's also supposed to be a then after if. It's totally fine if you don't write it. There won't be any marks cut for this. I generally don't write it myself, so it's totally up to you. So we have only one option here. Let's say the question says check if the time is midnight. So only one condition that you have to check. And then you will indent the code inside. Okay, so what does indentation mean? So why am I leaving this space here? This is the indentation part. So we indent the code. In fact, I'll write it above. Indent code inside if conditions would be indented, which means that they're part of the condition. Alright, so Python doesn't support curly braces like in Java, like in JavaScript. So that is why we have to indent the code in order to show that this code that you're writing is part of this if condition. This is just one way of defining the logic in a proper manner. So Python and pseudocode both. Then there could be another option scenario where you have exactly two options, like number could be even or odd. Number could be prime or not prime. Number could start with an A or not. So here you will have an if and you will have an else. That is exactly how we say things in real life. Like you can say, if I'm hungry, I'll eat, else I'll wait. So same logic applies here. And then we have to always end if. If you don't write end if, you will end up losing marks. Then we have the third scenario, which is more than three options, more than two options in fact. So let's say you want to pick a grade for the student. So there would be multiple conditions. You'll first check if the marks are between 90 to 100. So you'll assign them an A star. Otherwise, you will check if the marks are between 80 to 89, then 70 to 79, etc. So on and so forth. And the last else here is optional. Okay. So it totally depends on the question. Maybe you would end up using all the else ifs, or maybe there could be an else as well. So the number of else ifs is not capped. You can use as many as you want depending on the logic. Now we'll look at some questions. So ask the user to input a movie name. If it is Inception, output good. Okay, so the general format of any question would be that we'll always start with declaration. So first we'll declare. So declaration, then we'll have input output, then we'll have some sort of logic, and then we'll at the end we'll also end up outputting whatever data the user has to see. So first of all, we declare movie as string. Again, you can name them in any way you want, and then you have the enter movie name. Then you input whatever the user basically inputs, and then you check if the movie is equal to Inception, then you output good and you end if. That's the idea. In fact, there is one more thing that we'll need to be looking at, which is how do we name the identifiers. So let's look at them quickly. So how do we name identifiers? So there are some rules that we need to follow. First of all, no spaces, then no special characters like dollar, like percentage, then no keywords, like in Python we have output, we have input, etc. We have declared, and then must not start with a number. So these are some rules that you need to follow, and you can have uppercase, lowercase, you can add underscore as well. It's totally up to you. So some names that are correct would be, let's say, my name. This is correct. Then maybe total score like this. And then some wrong names would be my name like this and 1, 2, 3 total. So these are both wrong because there is a space here and because it starts with a number. Going back, so the next question is ask the user to input a number, output okay if it is even, otherwise not okay if it is odd. Okay, when you have to do a question like this, the best way to understand the problem is by visualizing a solution on the paper. And by visualizing, I mean you can always draw some sort of a trace table or you can set of dummy values. So what that means is I'll take input from the user in, let's say, val, and then I'll show some output. So when I input 2, the output should be okay. When I input 9, it should be not okay. When I input, let's say, 4, it should be okay. And if I input 8, it should be again okay. So this is how our program is supposed to behave. And since you're writing pseudocode, you can't test it on paper. So this is the only way you can. You can write a bunch of values, a set of values, write the code, and then test the code after you've written it to make sure that it is working properly or not. So how do we write the code for this? What do we need to do? So we need to have some sort of a number. Then we need to take its modulus by 2, right? So a number is even. So even means that number is divisible by 2. And whenever we have to talk about divisibility, we'll always end up using mod. So that is what we'll do. So we'll declare a number, we'll ask the user to input a number, and then we find the modulus. If the modulus of that number by 2 is equal to 0, which means that the number is divisible by 2, then we output okay, else output not okay. Now since there is no other possibility, a number could either be even or odd, so I can use else here. Or if you want, you can use else if here as well, and you can write mod num comma 2 is not equal to 0, then that means not okay. Or you can also use is equal to 1, because any number divided by 2 would either get a remainder of 0 or 1. So this is the whole code for writing this program. These hashtags that I'm adding are basically the comments, which means this is not part of the code. These are just there for the purpose of any programming. So this hashtag that you see, this is part of the comments in a program code, which means this code would not be read by the translator, interpreter, or compiler, and these are just there for the convenience of a programmer so that others can understand what you have done. All right, so then the next question is ask the user to input a number, output positive if it is greater than 0, then negative if it is less than 0, or 0 if it is equal to 0. Okay, so again, we'll draw some dummy values. So we'll have value and then we'll have some output. So if I input 4, it should output positive. If I have minus 9, it should say negative, and 0, it should say 0. And then if I have 3, maybe it should again say positive. Something like this. How do we know that if a number is positive? You must always check that by checking it against if it is greater than 0, negative is less than 0. So this is a bit of a straightforward question. I'll keep it here. And again, the code is very simple. First, we declared the number, we ask the user to input the number. Then there would be three conditions now for positive, for negative, and for 0. So if the number is equal to 0, output 0. If the number is less than 0, negative. Or if the number is greater than 0, positive. Okay, here we can also change the order of the if conditions. So maybe you can first check if number is greater than 0, and then here you can write positive. Or you can, since we know that there are only three possibilities here, it is greater than 0, less than 0, or 0. So we don't need this else if. We can just convert it to else, because we know 100% that they know the possibility. So if the number is not equal to 0 and it's not negative, then it's definitely positive. Or if you want, you can keep the else if here as well. It's totally up to you. And then we end if. And you can look at the indentation here. This means all of the code that we're writing here is part of this if condition. This output is part of this if condition. This output is part of this if condition. So if I quickly show this in Python, value is equal to int input enter. Okay, so I'll input a value now. If I input 5, it says positive. If I input minus 3, it says negative. Okay, so the code is working perfectly now. Again, Python is not part of the syllabus. This is just to show you how the program is going to behave. If you unindent this output, so you will lose marks for wrong syntax or wrong logic, because now you're saying that this output is not part of this if condition, which is not correct. And you can leave as many lines as you want. This actually helps in improving the readability of the code. Okay, then this is a program that will be carrying with us. We'll build upon it incrementally so you can understand all the concepts that we're doing, and you can appreciate how each concept will complement the other one very nicely. So we have a number guessing game, and in that number guessing game, you are supposed to assume a variable, and you have to ask the user to input a guess number. It could either output too high, too low, or correct if you guess it correctly. So again, let's first visualize the game. There would be a guess input. So first of all, there would be some sort of a truth here. Then we have a guess, then we have the output. So if the truth I save as, let's say, 15, and my guess is 13, so the output should be too low, or maybe you can say guess higher. Okay, in fact, we'll change that. So this should be guess higher. So we're giving user a hint and guess lower. Similarly, if the truth is again 15, and if I input 11, so I'll say guess, my bad, this, let's say if this is 16, so it should be guess lower, and then if it is equal to 15, then it outputs correct. So you can all see that we'll have three if conditions here: one for high, one for low, and one for exact matching. To write the code, again, first we'll declare the values. It's always a good idea to declare the values at the end, because in the start you do not really have a good idea how many variables you're going to use. So we set truth to 20 initially, then we ask the user to input a value by first outputting on the screen enter guess, and then we check if guess is greater than truth, then output guess high, else if guess is less than truth, then low, and if they both match, then that means they're both equal, so you output correct. With this, we are done with if conditions. Now we move on to the next topic, which is nested if conditions. So what is nested if condition? Nested if condition means an if condition inside an if condition, and the idea would be that there would be dependency on multiple if conditions before you take an action. So in order to understand this, I have just a general scenario here. So let's say you want to watch TV show, or you want to stay. Now you can do only one of these things at a time. So when we talk about TV show, in the TV show we have multiple options. We can either watch an anime, or we can go for a Western show. And then if we want to watch an anime, then we have these three options. We have the Attack on Titan, we have Full Metal, and then we have Death Note. And if you want to go for Western, we have Invincible and Samurai Jack. Okay, so in order to choose between them, what would be the exact set of steps that will follow? So let's say I want to go for Invincible. So for Invincible, first I'll need to pick a TV show, then I'll need to go for Western, and then I'll need to go for Invincible. Let's say next time I want to go for Death Note. So for Death Note, I'll go to TV show, then I'll go to anime, then I'll go to Death Note. So that's the idea. So let's say if you do not pick a TV show, then you directly skip. And let's say if you choose a TV show and you do not choose anime, that means you choose Western. So this is the idea of nested if condition. So here you have levels of indentation as well that you need to look at. So we have levels of indentation. So this could be level 1. Again, this is just for my way of understanding or way of teaching it. You can do it any separate way. So this would be indentation level 1. This is level 2, and then these are all at level 3. So if you're at any one of these levels, then you look at the corresponding level, not on the inside, not on the outside. So if I'm at the indentation level 1, then the corresponding other condition would be at line 13 here. So this would be at level 3. So let's say if I don't want to watch a TV show, so corresponding to my level 1 indentation, I have steep, so I'll steep. Then let's say I want to go for Invincible. So for Invincible, I'll first go to indentation level 1, then on 2 I will decide whether it's anime or Western. So I'll go for Western, and then from Western I'll decide between the level indentation 3 to choose between one of them, and I'll go for Invincible like that. And let's say if you choose Invincible, that means you are ignoring all the anime. And let's say if you're choosing the TV show, or let's say you're not choosing the TV show, that means you directly go to line 13, which is the other condition on level 1 indentation, which is to steep. So this is what you have to take care of. This is the idea behind nested if condition. So I'll leave it as it is, and then we'll try to solve some questions here. So let's see if we convert this logic to pseudocode, how does it work? Again, this is just an example to quickly show. So first I'll ask enter TV show, movie, or any other number to steep. Then I take the first choice as input. So they either choose anime or Western. So if they input the second choice and they choose one, that could either be anime or Western. So let's say if they don't choose anime, so if they enter 2, so from line 10, I look at the indentation that is corresponding to line 10's level, which is level 2 for now, because this is level 1, this is level 2, and level 2 alternates here at line 22. So I'll directly go to line 22. I'll skip all of this code, and it makes a lot of sense as well. This is exactly how you take decisions in real life. And then you look at this, and then you have to make a further decision in a nested if condition inside as well, and then you can choose from here. So let's say you go for samurai jack, this time it outputs and then it ends. Now next time you choose the first choice as 2. So since 1 is not equal to 2, so from line 6 we go to the corresponding if condition, and there it is, else if, and then we check is it equal to 2, so we print steep, output steep, and then it ends. In fact, this should be output not print. This is how your nested if conditions are supposed to work. And then please make sure that you close the if conditions properly as well. So this is my outer if condition closed, then on the level 2 we have this if condition closed, then on level 3 we have this if condition closed, if this ended, and that's the idea. Ask the user to input an integer value, output OK if the value is positive and it is multiple of 2 and 8. If it is not a multiple of 2 and 8, then output no multiples. Otherwise, if the value is negative, output not acceptable. Okay. Again, before we do the question, let's visualize it. So we have a value. Here we have to check if, and here we have to output something, basically. So if the value is -5, we directly output not acceptable. If the value is, let's say, 9, so 9 is not a multiple of 2, neither it's a multiple of 8, so I'll just output no multiples. Then let's say if I have 10 here and 16 here, so 10 is a multiple of 2 and 8. In fact, it's not a multiple of 8, so we haven't decided what to do here. So we can just leave it empty. It won't output anything. And if we have 16 here, so 16 is a multiple of 2 and 8 both, so then it will output OK. So now you can plan the program. First of all, you have to check if it is positive or if it is negative. So the first condition would look like this. So if value is positive, then we have to check for the multiples part here. Else, if the value is negative, then you have to output the error like this. Okay, now inside this if condition we check for the multiples part, and if you remember the multiples part, we always have to use the modulus operator here. So first of all, we checked if it is positive, then we check if it is multiple of 2 or not. To check if it is divisible by 2 or not, I'll find the first remainder, which is modulus of that value by 2, like this. Then the second remainder would be modulus of that value by 8, and if both values are equal to 0. So if remainder 1 is equal to 0 and remainder 2 is equal to 0. Why 0? Again, because that is the only time when the value is divisible. So if I write 16 mod 2 like this, you can see it's the modulus is 0, and if I just make it 17, so now it says modulus 1, which means it's not a multiple of 2. And then if that is the case, only then inside I indent the code and I'll output OK like this. Alright, and if it is not a multiple of 2 and 8, so I just saw that we have to output no multiples, so I'll just write else and I'll output no multiples, and as always we have to close this if condition, and this works perfectly. I'll just get rid of this. So that's the code here that I've written, and so in the approach here that I've implemented, I've used modulus here directly, so you can use it directly as well, or if you want to avoid some sort of cluttering in the code in the same line, you can go for this approach by separating out the variables here. In fact, I'll just get rid of this and we can follow this approach for now, and this has to end as well. So now if the value is negative, we'll directly go to NA, and if the value is positive, we'll find the remainders. If they're both multiples, then we output OK. If they're not, then we say no multiples. So in case of 10, it should also output no multiples like this. Then we have another question. Okay, so in this question we have to ask the user to input 3 values and we'll output their sum and average if they are positive and between 1 and 100. Okay, so for this again we can visualize. In fact, I think we can do this question directly. We have done enough visualization for the previous questions. First you have to check if they're positive and between 1 and 100. So if they are between 1 and 100, it automatically means they're positive as well, or you can check it otherwise as well. So if that is not the case, we should say if not positive values, output negative or invalid, something like this. Okay, so we are going to declare the values. We are going to set the sum to 0 initially, and since we have to input 3 values, so we'll input them together like this, input v1, v2, v3. Then we check if all of them are greater than 0, which means all of them are positive. All 3 should be positive. And if you use or would mean either one, v1 could be positive or v2 could be positive or v3, so that would be wrong. And then we check if the value is between 1 to 100. So if the value is greater than 0 already, so we actually don't need to write this. This is a redundant code because we've already checked it's greater than 0, so we can just check if it is less than 101. But let's say I change this range and I check if the value is between 80 to 100 like this. Now we need to change this. We'll check if v1 is greater than equal to 80 and v1 is less than 101 or v1 is less than equal to 100. Same here and then same. So I'll just keep it 79, 79, 79. So here we are checking all three conditions and then we sum the three numbers if and only if the values are positive and if value 1 is between the range and v2 and then v3. And you can clearly see the brackets here. So this means first this if condition will give you either a true or a false, then this if condition will give you a true or a false, and then this if condition will give you a true or false. So this is how it would be evaluated. You'll get a true or false here, and you'll get a true or false here, and you'll get a true or false here, like this, and then they would be added together. So let's say this gave you a false, this gave you a true, and then this also gave you a true. So false and true overall means false, because all the conditions must be true for and to be true, exactly like this. And then we average the values, we output their sum and we output their average. So this comma here means that total will be outputted literally and sum will print the value of sum. So if I just show you this in Python quickly, let's say we input a value and we say comma val. So if I input 12, so it says you entered 12. So you can see you entered is printed literally and val is replaced by the value of val that we inputted early on. Same logic applies here. It'll say output and it'll say total here, and then total would be followed by sum. The value of sum could be, let's say, 30, so it would output total 30 without the quotation marks. I'm skipping this question. You guys can do this on your own. Then we have this great calculator. So we have tried the pseudocode for this. We have these values 90 to 100, 80 to 89, etc. So we can always ask the users to input one if they want to see the grade, or two to exit the program. So if they input one, then and only then we'll ask them to input the marks. And then if the marks are not valid, so we'll output invalid. Otherwise, so here we'll now write the nested if condition. If the marks are greater than equal to 90, so again we don't need to write for 0 because we already know for sure that if the value is not less than 0, it should be greater than or equal to 0. So we can check for 90, for 80, for 70, for 60. We can output them and then we end if this if, and then we have the second choice and then we end the program. This is how it's supposed to work. And then we will again add some features into our number guessing game. So assume a number in the variable truth and ask the user to input the number. So the new thing we'll add now is ensure that the guess is between 1 and 20, otherwise output out of range guess. So before we did the number guessing game, so we wrote this and I'll bring that here. So now what we have to do is all the values here were between the range of 1 to 20, but here if I write 30, it should output out of range. That means your game will only work if the value is in the range. So how do we do this? The code remains the same, except now there would be another if condition which will check if the value is out of range. So you check if guess is greater than 20 or guess is less than 1. Or there's another way of writing this. You can say if guess is greater than equal to 1 and guess is less than equal to 20. If that is the case, you will put all of this code in under line 25. Or if you want to keep it that way, that is also fine. You can first check for the wrong condition and then you can do the right one. So if guess is greater than 20 or guess is less than 1, out of range guess. And then if that is not the case, so inside the else you can check if it is low or high, or it could be correct, and then we end if this inner if and the outer if condition. So this is now an incremental version of our number guessing game, and it is also improved now because the previous one had no upper bound. The user could keep inputting invalid values and it will still accept them. Now the second part of selection statements are case of otherwise. So case of otherwise are just an alternative when you have multiple else if conditions. So it should be ideally used when there is a lot of else if condition involved and a single line of code in each condition is written and there are no nested if conditions. Okay, so this is like the ideal scenario. It's up to you when you want to use it. Okay, how do we write case of otherwise? This is the pseudocode syntax for this, again taken from the pseudocode guide. So we write case of, then we have the variable name, then we have the first condition, we have the colon, then we have the some action performed, then we have the second condition colon, and then as many conditions as you have. Then we have the otherwise clause in which you will perform some else action. So this is equivalent of else. So he will perform an action and then will end it using end case. So let's look at an example. they could ask in the paper that you need to convert an if condition into in case of otherwise, or you can convert a case of otherwise into an if condition, or for the most part you're given liberty to choose whatever you want. So let's say we have this calculator implemented using if conditions. Now you want to convert this into a case of otherwise. So we have the positive, negative, multiplication, division, and then we have the invalid operation. So for case of otherwise, we'll input the operation. We should always output a message as well. Enter an operation plus, minus, multiply, divide, and then we apply case of the operation. So plus, if it is plus then colon, then this is the action we're performing. For negative, this is what we're doing, multiply, divide. And in case of otherwise, if you don't input a correct operator, then we output invalid operation, and then afterwards we simply output the result if there is a result. And that's it. So you can clearly see this whole logic that we wrote here has been simplified into just 5 lines of code. So this is case of otherwise. There is a question here of again the number guessing game that we just created a variant of using the nested if conditions. So instead of checking if the guess is greater than truth, less than truth, we can just write it this way. So this is totally acceptable and fine. Okay, now we move to the fifth topic, that is iteration. So when we talk about iteration, iteration is the third concept of pseudocode, the third construct, and iteration means that we repeat a block of code. Now there are two types. We have the iterative or count controlled one, and then secondly we have the conditional one. Alright, so first of all, the count controlled one, in that we know the number of iterations that we will be using, so it runs for a fixed number of times. Like when we say that I'll study for 2 hours, I'll play football for 3 matches, here we are sure that this is how many times we will be repeating something. Now the syntax that we have to use for loop starts with for, then we have the variable, then we have the assignment operator, then where to start from, where to end, the code that will repeat inside. Again, the code is indented as you can clearly see. Then we have the next. So next means to add +1 in the variable value, or to go to next iteration. That's the idea of next. And in pseudocode, there is no way of breaking a loop if loop is not a word. So this is a very common mistake that students make. They always end up saying that if loop is being used. So if is not a loop, if will only run once. Your for loop or your while or repeat until loop is the one responsible for repeating a block of code. And then there is no way of no way of breaking a for loop. So we have to use some sort of mechanism to indicate from inside the for loop if we have found something or not, if our task is done or not. So we'll look at that. The second syntax that we have is syntax with step function. So here, let's say you have a for loop and you don't want to increment it by 1. So I told here that next will always increment the value by 1. So in case of step, now you can change the value by +2, by +5, by +10, by +7, -3, -2, however you want it. So we'll look at an example shortly. So the question is output all the values from 1 to 20. So what we do is we use for I, whatever variable you want, arrow 1 to 20. So 1 is the start, 20 is the end. And when I say output I, this means it will start from 1. Then next time means go to 2. So then it outputs 2, then 3, then 4, all the way till 20. So quickly doing this in Python for I in range 1, 21, print I. So it prints all the values from 1 to 20. Again, Python is not in your syllabus. This is purely for demonstration purposes. Then output all the values from 20 to 1. So we want to output the values in reverse now. So we are going to start it from 20 and we'll go all the way till 1. But now the step would be -1, because next I would make it +1, and if you don't want to increase it by 1, you can just add the step value which we are adding as -1, and we can do the same thing here. We start from 20, we go all the way till 0, and we want to make it till -1, so all the way from 20 to 1. So this is how we'll be able to use the for loop in reverse. Then if the question says output the even numbers from 1 to 20, so there are two ways of doing it. You can simply output all the numbers from 1 to 20 inside a for loop, and then you take the remainder by 2 by using the mod operator, and then you check if the remainder is equal to 0, only then you will output that value. So it will not, so the output wouldn't work for 1, so it will work for 2, 4, 6, 8, only the values that are divisible by 2. Or the second approach is that you can use the step function. You can start from 2 and you can go all the way till 20, and you can have a step 2. So the first value outputted would be 2. Then next time it will add 2 into the value of I. So 2 plus 2 would become 4. then it will output 4, then 4 plus 2 becomes 6, so it will output 6, and this will happen all the way till 20. So then let's do a question. Ask the user to input 10 values and output the count of positive, negative, and 0 values. Okay, so now we have to count. So in order to count, we simply create a variable and we write something like this. So let's talk about totaling and counting here, although we'll be talking about it again in next questions. So we have counting and we have totaling concepts. So counting means that we increment or decrement a value by 1. Always initialize the variable and then we change it. So same for totaling. Here we add values into a variable and then we also need to initialize the variable. So for counting, we basically say that count is initially set to 0, and then somewhere inside the program we'll do count is equal to count plus 1 or minus 1, and for totaling we do, let's say, total is equal to total plus some value. Whatever the variable names are, these are not fixed, you can change them. You can call it sum, total, overall, and for counter you can call it positive count, negative count, etc. So ask the user to input 10 values and output the count of positive, negative, and 0 values. So what does this mean? So we need to have essentially 3 counters now, right? So there would be, we will input value, there would be a positive count, let's call it PC, then we have negative count, that is NC, and then we have ZC, and then we need to output their values. So for the first value I input is 12. Okay, we need to make sure that all of them are set to 0. We discussed that the programming language doesn't know if they should be, what should be the default starting value. So the first value is 12. This is positive, so program counter 1, sorry, not program counter, the positive counter becomes 1. Then I input 9, it becomes 2. I input 0, so 0 count becomes 1. I input minus 5, so now negative count becomes 1. I input 0 again, so 0 count becomes 1, 0 becomes 2. Then I input another positive number, let's say 42, so this becomes 3. And this whole thing will repeat 10 times, right? So this is what you have to do. Every time you see a positive number, you increment that counter, same for negative, same for 0. So this is the visualization of our program. So we'll declare the values, we'll set them all to 0, we run a loop for I 1 to 10. Okay, now we can have any if condition inside the loop, or we can have any loop inside an if condition. Now all of these building blocks will be coming together to form larger and more complicated program. So for I 1 to 10, we need to input the number. So user will input a number. Let's say the user inputs 12. So is 12 greater than 0? Yes, it will change the positive count by 1. So from 0 it becomes 1. And then from this 924, since they are all connected, we directly go to end if. We go to next time, so now I becomes equal to 2. So I will repeat for the second time. The next value that we'll input is 9. So again, positive count would be increment by 1, so on and so forth. This is the whole program, and at the end we will just output the values. The reason we are not doing this inside the loop is because we don't want to print them 10 times. So this would give you 30 outputs, 10 times 3. We only want to output it once at the end, unless the question states it otherwise. So that's the idea. Now using case of otherwise, so if you want to do this differently, so you can just change it here. So in the whole code remains the same, and for positive, negative, 0, so you can just say greater than 0, less than 0 is equal to 0. We've already talked about totaling, we've already talked about counting as well. So in fact I can get rid of this. Then this is an important algorithm. How do you sum the values and how do you average the values? Okay, so again we'll draw a small trace table. We have some value and we have some sum here, and then we have some output, or we have the count. Let's call it positive count. So sum and positive counter again set to 0 initially, and we input the first value, that could be 4. So the sum becomes 4 and positive count becomes 1, and we'll also have the value of I, the loop variable. You can call it anything you want. Let's call it j this time, and it will be 1 initially. Then you input 0, so the sum remains 4, positive count doesn't change, I becomes 2. Then you input 10, so 10 plus 4 becomes 14 now, and positive count changes to 2, and now your loop has run 3 times. Now you input minus 4, so minus 4 will, so the question says only sum the positive values. Okay, minus 4 will not be added to the sum, it will not be added to the positive count, but it will be counted as a number. Then I input 25, so 25 plus 14 would be 39. Positive count becomes 3, j has run 5th time. Then maybe I have 1, it becomes 40, positive count is 4, and j has run 6 times, so on and so forth. Okay, so this is the whole idea of how the program should behave. So once we understand this, now we can write the code. So we'll set initially the sum and program counter to 0. Also, when I was talking about totaling, so we have to remember that this is always done inside a loop. So using the current value of total, we add a random number and then it updates the total value. So here we have a loop here. We check if the number is, we ask the user to input a number. So if the number is greater than 0, only then we add that value into the total. And then we increment the counter by 1 and then we end if. So let's say if the number is not greater than 0, if it is -5, so is -5 greater than 0? No, it goes to end if and then it goes to the next iteration of your for loop. So this is the whole program, and then we have to output the average. So output average means dividing the total by the number of positive numbers that we counted before. So let's say there were 4 positive numbers, like in our case we had 4 positive numbers, so we'll just find the average like this. Then we have the other question: ask the user to input a number, output all its multiples from 1 to 10 in this format. 5 multiplied by 1 is 5, 5 multiplied by 2 is 10, etc. So we have to do it for 10 values. Okay, now you can clearly see that 5 is the constant number, so we'll take this input only once, and this 1 2 3 4 5 is going to change, and for that we can directly use a while for loop which will run from 1 to 10 times. So we can run it from 1 to 10 times, and every time we can multiply the current value of I with the main number. So let's say main number is 5, you multiply 5 with I is initially 1, so you get 5, then it's 2, it becomes 10, then 3, it becomes 15, so on and so forth. So then you can output main number multiplied by I is product, and product will contain the multiplication operator. You can just plug in some values here and you can understand the code easily. I'll be skipping this question. Okay, then the next topic we have is how do we find the maximum and minimum values that the user will input. Okay, so this is an interesting question. Here what we have to do again, so we can go into this file here and we can visualize the values here. So we have some values, we have the maximum, we have the minimum here. So since we do not know what the range of numbers would be, we can assume that the first value that the user inputs will be the maximum and minimum. So the user inputs 13, so we assume that 13 is max and 13 is minimum. Now next time the user inputs 5, now 5 is not greater than 13, but 5 is less than 13, so minimum becomes 5. Next time we input maybe 7, so is 7 greater than 13? No. Is 7 less than 5? No. Then we input 25, so is 25 greater than 13? Yes, so 25 becomes the max, and 25 is not less than 5, so we don't check. And maybe let's take one more number, maybe I input 0 now, so is 0 greater than 25? No, but 0 is less than 5, so 0 becomes the new minimum. So the maximum value overall and the minimum value overall is 25 and 0. So this is the whole concept that we are looking at here. So what do we do? So we have already visualized this. So there are multiple ways of doing it. Again, there are multiple ways of solving any problem. You don't have to stick to my code. So the first time you input a value, assume that this is the maximum and minimum number. Again, we do not want to second guess the range of the number, so that is why we're doing it. Because what if the user inputs all the negative values or all values in millions? So you can't assume any range for the maximum or minimum. So ask the user to input 5 integers and output the maximum and minimum. Only consider values between -10 and 20. So I'll comment this out for now. We don't need to do this. Okay, so I input 5 values, and inside the loop user will input a number, and once since it is the first iteration, so I'm checking if j is equal to 1, as in the loop ran for the first time. So then you are setting the max to number and minimum to number, and then you end this, and then this is the main part. So the next time you have a value 5, you check it against maximum and minimum. So you check, is the current value greater than max? If that is so, then assign number to max. This value would become max. So 5 doesn't become max here, but 5 definitely becomes min. So we check, is 5 less than 13? Yes, so 5 would become the minimum, and this is exactly what happened here. And then this will repeat for the second time. So when j becomes 2, this condition would not work, and then it will repeat for the second number, and then it will check again if it is maximum, minimum, and this whole process will repeat, and you will end up getting the correct largest or minimum value. So if you don't want to do this, you can also just take an input once outside the loop, and that would change the logic here. So you can take the input here, and then you can start, and then you don't need to take the input first most, so you can just get rid of this code here. You check if the current value is maximum or minimum, and then at the end you input the number, ask the user to input the number, and then it will repeat for 4 times. So totally up to you, however you want to do it. Now we again look at the number guessing game. So in the number guessing game, assume a number is a variable truth. So here we have to ask how many chances they have to repeat the game for. Okay, now everything is the same from the nested if condition. Now we will ask the user how many times they want to repeat the game. So first of all, we will ask this, and then that is the number of times we have to run the for loop for. So if they ask, okay, I want to use 5 lives, that means the loop will run from 1 to 5, and then everything else remains the same inside. We just wrapped it all inside a for loop. So now the game is getting better. We started with very simple game, which was only running once. Now it is checking for if the value is in the range or not, and then now the user is also able to input on their own how many times they want to repeat the game. So that's the idea. Then the next thing we'll be looking at is the conditional loop. So here we would not know how many times the loop has to run in order to be satisfied with the condition. So the loop runs for loop runs for a fixed number of times, and the iteration is already known. Like we talked about it. So I'll play FIFA for 2 hours, I'll jog for 3 kilometers, etc. But in conditional, you do not know the number of iterations. The loop keeps running based on a condition. So some example, like I'll play FIFA until I'm sleepy. So here is no upper bound. While I'm not tired, I'll jog. While I'm not tired, I'll read. Again, you do not know when you'll get tired. Maybe after 10 minutes, maybe after 1 hour, maybe after 5 hours. We do not know. So this is what conditional loop does. So there are two types of conditional loops. You have the preconditional loop, and then you have the post-conditional loop. In the preconditional loop, we check if the condition before entering the loop, and we check if the condition is not true, the code will not execute at all. And in the post-conditional loop, we check the condition at the end, and the code will always execute at least once. So this is the main difference. Also, in conditional loops, you do not have counters. You have to manually increment or decrement the loop variable, unlike in for loop. So you guys remember that in for loop, we have this function that automatically changes the value of I that we saw above as well. So for I 1 to lives, and this next I changes it by 1 automatically, but not this would not be the case in conditional loops now. Okay, so syntax. So the syntax for preconditional loop is you check while the condition is true, repeat some code, again we indent it inside, and then we do end while. And for post conditional, we have the repeat until. So it will start with repeat. You do not write anything next to repeat. Here you write the code inside, and then you check the condition at the end. And since you're checking the condition at the end, the code will always run at least once, even if the condition is false. Okay, now let's do some questions. So output all values from a start till the end inputted by the user. So now the user will tell you where from where to where you have to output the values from. So in for loop, we run for I start to end, and start and end are undefined. We need to take them input from the user, input start and end like this. You can put brackets or you don't, and then you also should output enter start and end ranges like this. So whatever the user inputs, let's say they input 5 comma 10, so it will output all the values from 5 to 10 like this. So this is using a for loop. Now if we have to do the same thing using a while loop, we first need to ask the user to input the start value and end value, and then we need to have a loop variable. So like here we have I, which is starting from start initially. Now we have to do it manually. So we set start to I. So let's say the start is 5, so I becomes 5. And then we are checking while I is less than or equal to end. So essentially if end is 10, so we are saying is 5 less than or equal to 10? True. So then you first output the value of I, which would be 5. Okay. If you only leave it here, then this is going to go into an infinite loop, because you are not going to change the value of I. Again, it will check is 5 less than or equal to 10? Yes, output 5. Is 5 less than or equal to 10? Yes, output I. So if I were to show you this in Python, let's say value is equal to 5. So we say while value is less than or equal to 10, print val. And if I print this, so you can see it goes into an infinite loop, because this condition will never become false. So that's the idea. So in order to make it false eventually, we always have to change the counter by a certain number, as you saw in the for loop where you change it by 1 using next. So here you have to increment it by writing I is equal to I plus 1 manually. So this is your while loops, and this will run perfectly now. And same thing applies on repeat until. You set start to I. Then again, I is just a placeholder name. You can use any name of your choice. So you say repeat until. So now the condition of until and while would be separate, because they are different in terms of logic. So you say while this is true, you keep on running this, and whereas in this loop, post condition loop, you say keep on repeating it until the condition becomes this. So until I becomes greater than end. That means until 5. So I is 5, then 6, then 7, then 8, then 9, then 10, and then once it becomes more than end, as in more than 10, so this loop should stop. So that is the idea here. Now we have another question to look at. So sum all the values that the user inputted until minus 99. Okay, so how do we do this? Again, we have a value and then we have a total. So total will be set to 0. So the user inputs 50, so total becomes 50, 20 it becomes 70, and 30 it becomes 100, and then I input minus 99, and then the program should end. So it should not add minus 99 into the loop. Okay, so looks very straightforward. First of all, we cannot use a for loop here because you do not know at what point will user input minus 99. It could be in the first try, it could be in the second try, it could be in the 10th try, we don't know. How do we write this? We can use a while loop here, or we can use a repeat until here. So in order to do this in using a while loop, first we have to declare a number, then we take the input of the number, and then we run the while loop on it. So there is a very common mistake that students do. They don't take input into the loop variable and they just check while number is not equal to minus 99, and this number is not defined. So if I just change this to num here in while loop, it says num is not defined. What are you referring to? So here we always have to take the input first or assign an initial value here. So I'll take the input. So I'll check if the number is not equal to minus 99, then you will add that number into the total, and then you have to take the input again, otherwise it will go into an infinite loop. So this is the not equal to sign. So let's say the first value is 10, 10 is not equal to minus 99, so 10 is added into the total, then you input the value again, let's say 30, 30 is not equal to minus 99, it adds 30 plus 10, it becomes 40, and then now if I input minus 99, so I go all the way up. Is minus 99 equal to minus 99? Yes, goes to end while, and it will print the sum of values as sum of values would be 40, like this. So this is how you have to do a question like this, and you can do it using repeat until as well. So the next question is, ask the user to input a password, and then you have to ask the user to input a confirmation password and keep repeating confirmation password until it matches the original one. If it is matched, then output logged in after n tries, and here you have to actually output n number of tries. Okay, before we do this, let's quickly implement this using a while loop, a repeat until loop as well, using repeat until. So in repeat until, we don't have to take input outside the loop because we can directly start as the condition will be checked at the end until value or num is equal to minus 99. So now you ask the user to enter number, and then you input that into num. Okay, and then you add that into the total, and total is initially set to 0, like this. Okay, now this is going to cause an issue, because let's say if the first number you input is minus 99, it will end up adding minus 99 into the total, and once you output it outside the loop, what the total is, so it will literally print minus 99. Again, we are checking the condition at the end. So if you input the wrong number, if you input the condition terminating number, so it will still not be checked. So we have to explicitly add another if condition here, and we have to check if number is not equal to minus 19, only then, and add this into the total. Okay, so this is how you have to do it using repeat until. Okay, so here we have to ask the user to input a confirmation password until it matches the original one, and then we have to output how many tries they took in order to get it right. So here is some visualization. Let's say the password was the matrix, and the confirmation password we wrote it multiple wrong attempts, and then the tries change from 1 to 3, and then you get blocked. In fact, we don't need to output this. We can just say logged in after 3 tries. Similarly, here we also do the same, and we'll say logged in after 2 tries. So the final try wouldn't count, or you can count it if, again, it depends on the question. So here we have the password, confirmation password. We set the count to 0. We input the password once, we input the confirmation once, and we're using a while loop here. You can use it, you can do it using repeat until. We check if they both are not the same, then you increment the count of tries by 1, and then you ask the user to input the confirmation password again. This keeps on repeating until they both match, and after the end you will output logged in after this many tries. Again, we have the mini project of number guessing game now. So now we can keep playing until the guess is correct and how many tries the user took. So same code as before. Now we can just replace the for loop by a repeat until, and we can say that until guess is equal to the truth. So the truth is set to 20, and guess is what the user inputs every time. It could either be out of range or it could be in the range, and every time we guess, we check if it is not equal to the guess or the truth value, and we increment the value of tries by 1. So until guess is equal to true. That is why you don't see the third condition here, because we can just output it out afterwards outside the loop, because this line will only run when line 34 is done. That means eventually guess, when it becomes equal to truth, then this line would be output. So you don't need to put this inside the loop. If guess is equal to truth, then output, etc. So this is using a repeat until. Okay, now we talk about library routines in the sixth topic. Okay, so the source I'll be using, as I showed in the start of the lesson, this is the insert document that you get for all the papers. And I'll just quickly sort of pass this. So we have left, right. So these are the library routines that are given to you that you can use directly in the exam without having to implement. So library routines are built-in functionalities supported by programming languages. This allows operations to be called directly without writing code for them. Again, going to a Python example, let's say we have a string comsci, and if I print the length of message, so it will directly output 8. So I did not write the code for length. I did not tell it what it has to do, but it still ran because this is part of the library routine, which is already given in the programming language. So these are the functions that we have. We have left, right, mid, length, lcase, ucase, etc. So some of the important ones here would be length, ucase, lcase, substring, round, random, div, and mod. And I'll walk through them. So left will return n number of characters from the left side. Right will return n number of characters, 3 characters from the right side, and you'll get fgh. And you will not write string and integer when you write in the actual values. These are just the formats. Okay, so we'll be looking at structured programming in a bit as well. Then we have the mid one. So mid allows you to pick out some part of the string. Length tells you the number of characters. Lcase, ucase, you can do them on your own. Then num to string, string to num are used to convert number to string, or you can also convert the number to char. Here it says so. And similarly the same case here. Then we have int and rand. So rand would be used to generate a random numbers. So random is used in IGCSE O level and rand is used in A level. So rand will generate a number from 0 to the number that you pass in, but not including that. So when you say rand 87, it means from 0 till 86. And this will always generate a real number. We don't want a real number at times, so we can always use the int function to convert this real number into integer by trimming off the decimal part. Then we have the date format. So we have day, we send the date here, so dd, tetra y. So we have the month, this will separate out the month. We have the year, this will separate out the year from a certain date. Then we have the day index. So day index will return the current day index from this date. So that means if you have 12/05/2020, this will tell you the exact day index at what day it was, and it will return with an integer, which is 3. Since Sunday starts on 1, Monday is 2, so 3 would mean that this was a Tuesday. And then you have the today, this will return today's date, and set date will allow you to set a date. Then we have EOF, this is end of file. We'll look at it when we talk about the text file handling, and then we've already covered these. So this is what you have to do here. We have done round, random, etc. So let's say if you want to generate a random number from 20 till 50, so you will use rand till 31. So this will generate a value from 0 till 30. And now you want to start the range from 20, so you will add 20 in the random value, and you convert it into int, into integer number. So let's say rand 31 generates a 0, right? It can generate a 0, so 0 plus 20 would mean smallest value would be 20. And let's say it generates a 30, so 30 plus 20 would mean 50, and any number in between them would be totally acceptable. Then we have already covered these. So length, ucase, cellcase. So let's say we have mid, and let's say we have the game name Last of Us. So if we want to extract us from here, so we put in the game name, the string, we put in the game name, then we tell it the starting index, which is 9. So we count 1, 2, 3, 4, 5, 6, 7, 8, 9. And from the ninth character, how many characters do we need? We need 2. So we write 2 next to it with comma, and then it gives us us. Then how do I count how many times a certain character appears in a string? So let's say we have this message here. Maybe so we have the World Wide Web, and we want to count how many times W appears here. So we know that it appears 3 times. But we don't have to do this manually, we have to do this in a programmatic way. Okay, and you can clearly see that these are all in uppercase. So just to be on the safe side, we should be converting our strings into uppercase to make sure that they both match, because programming languages are case sensitive, so it won't work. Also, lcase and ucase works on character, so we'll be talking about 2 upper and 2 lower. So here we have to use 2 upper. So this changes like this. So now we have World Wide Web, and we'll assume that this was initially something like this. So how do I count how many times W appears in this string? The idea would be that I should be able to separate out all these characters one by one and then compare if each of them is equal to W. If it is, then I'll add 1 into it. So how do I get one character out? We already saw that we have the mid function available to us, which is able to extract some part of the string. So I can just extract this one character and then move on to the second, then third, then fourth, and I do this for the length of the string. So that is what I have to do. It's a very straightforward question. So what I'll do is I'll run a for loop from 1 to the length of the string that I'm looking at, which is World Wide Web. So I guess it has like 12 characters. So the loop will run 12 times. And then every time I'm saying from the P, go to the Z index and get one character. So get one character from Z position, from index Z. Okay, what does that mean? So once Z is 1 here, so it says pick the first, starting from the first character, pick one character, that would be W. So here you get W. Then, so here we get W like this. Then when the value of Z becomes 2, so here you get 2 and this will get you O. Then it becomes 3 and it becomes R, so on and so forth. So here this is how you can get each character every time from using a for loop, and then you can compare if that character is equal to Q, then you increment the count by 1, and if the question says you have to also output where it was saved, so you can just save the value of the current loop variable into some variable. So you can save the last position in it and it will return that at the end. That's the whole idea. So we've already talked about these. Okay, then how do we create maintainable programs? This is a very small subtopic of the syllabus, so you should know because it is often asked in the exam. Alright, so maintainable program means that we use meaningful identifiers like variables, constant, data structures with relevant names. So let's say if you are using a variable to store your grades, so the name should be related to grades rather than classroom, rather than games, rather than some random words. Okay, then the commenting feature should be provided by the language, so it allows for the other team members to take note and to remember your own logic. So you've already noticed I've been adding comments. And then procedures and functions, this is a modeled approach where we break down the problem into smaller parts and we make it reusable. We'll talk about this in this very next topic now. So let's talk about structured programming. This is going to be a bit of a tricky topic, but hopefully it will make sense. So let's say we are playing Ludo online, and the simulation would be that there would be some sort of a loop in which the user will play, roll a dice, and then there would be some pieces on the board that would be moved. Then the player 2 would do the same thing, and so on and so forth. Here are certain functionalities that need to be repeated but separately. So in order to implement this, we don't want to repeat the code, we don't want to copy paste the code over and over again, we want to make the code reusable somehow. So for this, we will be looking at procedures and functions and a lot of theory related to it. So first of all, we have a procedure. A procedure is a set of programming statements that are grouped together under the name and can be called to perform a task at any point in the program. Then we have a function which does the same thing, but it will then return a value back to the main program. Okay, what does that mean? I'll talk about it. And then what does the return keyword do? It terminates the execution of the function and it returns the value back to where it was called from. Then there would be some other terminologies, like we have the parameters, which are the variables that store the value of arguments which are passed to the function or procedure. And then we have the advantages of using procedures and functions. So the code becomes more usable, which means it can be called multiple times. Then it is more easier to debug and it is more readable for other programmers. Okay, so what does this all mean? So first, let's look at a procedure and a function. So we have a username here and we have a user ID here, and every time the user opens a certain window in the program, it should output welcome back and then logged in with this ID. So if I input a username, let's say test, and the user ID is 123, so it says welcome back test and with ID 123. Now let's say I want to print this multiple times, maybe in the home page. Then I want to show it under the products page, then maybe under the attendance and services. etc. So one way to do this is I can just copy paste the code under each. So that would be a lot of repetition, and this is just a very tiny snippet of code. Usually the code would be much longer than that. So what would be the more efficient way? That would be that we'll create a module that can be reusable and in Python. So I'll simply do it, define, let's say welcome, and I'll put this inside the module, and then outside the module I'll have this what we call the main area. This is where we'll call the module, and if I call it and I run it, it will run perfectly fine. So test 1 2 3. Okay, so this runs once. Let's say this was inside the home page, and then I want to do the same thing under about us page, and I can call welcome again. So it says home page and the username test 123, and then ABC, and then 123, and it says welcome back ABC, logged in with ID 123, logged in with ID 123. So what happened here was that we first printed homepage, then we made a call to welcome. So we went to welcome in line 2. We completed all these lines. From line 7, we came back to line 12. Then we printed line 14. Then from 15, we went back to 2. We did all this and we came back to 15. And now this is successfully reusable. We don't have to make any repetitions or copy pasting of the code. Okay, now the idea of parameters is that we send the value through a variable and then we pass it to the module so that the module can consume that value to produce some functionality. That simply means that instead of inputting the value here inside the module, it depends. In fact, you can take the input inside, or if the question says that you have to pass in the value, then that means you'll need to use the parameter. So in parameter, what we do is inside these brackets, we will be writing the values. So let's say user and UID, and then we'll be inputting these values inside the main function. Or I can just simply pass in the values directly. I'll say test 1 2 3, and here I'll say test 2, and then 4 5 6. And if I run it, so you can clearly see it says welcome back test 1 2 3, and then test 2 4 5 6. So this is the idea of parameters. Basically, these are the values that will be consumed by the module. So you can either leave this empty if the program doesn't need the parameters, or you can send them as values as arguments from the main function or by taking input. Then the difference between a procedure and a function. So procedure will not return a value, function will return a value. Again, let's add loop here. So for I in range 100, print value of I, and then I say if I becomes equal to 5, then return simply. So if I call this now, so look at this, after 5 it doesn't print the value anymore. So return means that it will instantly return whatever value that you have, and it will terminate this whole module, and it will go back to the line it was called from. So it was called from this line 14, so this will bring the value back. So let's say you return value maybe -1, so you can cache that value here. Let's name the variable catch, and you can cache the value here, and if you print the value of catch, you can clearly see -1 here. So this is the whole idea. So now we'll look at the pseudocode part of it. So in order to call function in the pseudocode, we use the name of the function, and then we save it in a variable, and we can use it in the further parts of the program. And when we have to use a procedure to call, we need to write call, and then we write the name of the procedure. This is as per the subject requirements, syllabus requirements, so you have to kind of adhere to them, otherwise you will lose marks. Then we have local and global variables. So let's say you have this variable here, let's call it warning maybe, and warning is invalid details. And if I try to output value of warning outside the module, so it will say name warning is not defined, which simply means that this module is not accessible outside. Any value that you create inside will be deleted afterwards. So this is not accessible. So warning here is a local variable. But if I just move this warning at the top of the program or outside the module, now I can access it inside all the modules, and I can also access it outside the module in the main program. So you can say invalid details, and then you can also find invalid details here. So this works perfectly. So this is what a local and global variable is. So local variable is defined within the scope of a module and is not accessible outside, and global variable is defined through at the high scope of a program and is accessible throughout the program. Then we also have by val and by ref. So when we pass in a value here, so let's say if we have test 1 2 3 here, so test is essentially copied into user, and 123 is copied into UID. But let's say if even I were to use some variables here, so I say welcome, maybe val1 and val2, and if the user were to input val1 and val2, so I'm not going to take the input right now, something like this. Okay, so val1 and val2 the user will input. Now if you make changes into val1 inside the module, or if you make the changes to user, so val1 has no link with user, because this value that you're sending here, whatever the user inputs, maybe Adam, so this will be copied into this user. Okay, so the variables are not changed. So even if you try to change value 1 inside this module, it will not be reflected outside the program. This is the concept of by val. The value is copied into the parameter, and by ref we simply pass in the memory address of the variable in the argument. So now if you pass it by ref, that means whatever changes you make into this variable that was passed from here, so val1, whatever changes are made to val1 inside the module will be reflected in the subsequent parts of the program. And in pseudocode we use by ref like this. Okay, now we jump to the pseudocode part of it. So in order to write pseudocode for this, we write procedure, then we have the name, then we have the parameters which are separated by types, and parameters are optional, then we have the indented code, and we use call to call it, and then for function we have the name, then we have the parameters, and then we write returns, and then we have the type, whatever the type is, and then we have the statements, and then it must use the word return for it to be a function, and then in order to call it we use the name of the function and we assign it to some value. Okay, so write a subroutine that takes a parameter of count and then prints that many stars on screen. So we'll use a procedure because we don't have to return any value. Star printer, whatever the count user inputs will be taken as an integer in the parameter, and then will print that many stars. And then I can call it in the main function. So star printer 5, 5 is copied into count, so this will print 5 stars. Then 3, then it will print 3 stars. Similarly, if I want to print if a value is even or odd. So for that, I have this procedure even or odd, and we pass a parameter here, and we again take the modulus of that parameter by 2. If it is 0, then even, otherwise odd, and we can call it on as many values as we want, and it will still work accurately like this. And if you want to make it a function also, with the function we need to return a value. So we'll return an integer value like this, returns an integer value, and then we write if the modulus is 2, so we can return 0, and otherwise we can return -1. So what does -1 mean? The user does not know. So once we cache the value here inside x, we can just write on the screen if x was equal to -1, then that simply means odd. This is just an indication, okay, and else it simply means even, something like this. Okay, so this is just an indication. You can, in fact, you can just even return even or odd if the return type allowed a string. But if it is integer, so you have to kind of make integer, return integer values, and then you have to output it appropriately on the screen. Okay, now we begin with topic 9, which is arrays. Very important topic. So what are arrays? So arrays are a collection of items of the same data type which can be referenced using a single identifier, and there are some terms that we'll be using. So the term is index, which is the position of each element in the array, and then there's the value, which is the data stored in each element, and then the array in our syllabus can be 1D or 2D. Okay, so what is the syntax of an array? So the syntax would look something like this. You have the declaration, then we have the name, then we have to write column array. Literally we have the name, we have the column, we have the array, and then we have the start to end of, and here there should be a type, some type of the array. It should always be of one type. Then let's say we have an array declaration of games, so declare games as array with 5 elements. So you can do either 0 to 4 or you can do 1 to 5 of type string, so there would be 5 null values. Okay, so it would look something like this. I'll get rid of this, and so this is how the array would look like initially. It would be all empty. And then I can, in order to output one item of the array, so we cannot use output next to the array name. We cannot output it all at once. We need to output it one by one. So if I say output TV show index 5, so we're assuming, let's say, if there are some values here, so it will output that value. So this index is always wrapped in square brackets, not in round brackets, not in curly brackets. And then if I say input TV show index 1, so whatever is at index 1 will be replaced. So let's say user inputs community, so it goes on the first index. like this. So how do we output the values of the array one by one? Okay, so first of all, you cannot use the length function to find the size of the array. There's a reason for that. If you go to the insert document and you look for the length function, so it says length of this string, and it says representing the length of the string. Okay, it can only be applied on a string, it cannot be applied on an array, so please don't make this mistake. So the size of the array would always be given to you. So for I 1 to 5, you have to input values in here. So again, this is a null array, so we want to input 5 values in here, so we run a loop, and then I say input tv show square brackets I. What does this signify? So I could initially be 1, so whatever you input goes to 1, let's say ABC, or we have the show names here, so it goes there. Then I becomes 2, so whatever the user inputs goes on to 2, then 3, then 4, and then eventually 5. So one by one this is all done. Then I want to output the value of the array, all the values one by one. So again, I'll run the loop 5 times, and then I'll output each show at each index. So index 1, it will output this, then 2, then 3, then 4, then 5. That's the idea. Okay, now we have to do some array algorithms. So first of all, we have sum and average. Okay, this is pretty much like we've done for the basic values for numbers. So we'll repeat the same thing here. Now let's say declare and take input into a real type ratings, output the sum and average of the array. So we have this array called ratings. First we have to take input into the array. It has 5 values. So we run a loop 5 times, we output enter ratings, and then we input ratings index I. So it would be initially 1. So whatever you input goes on 1, then 2, then 3, then 4, then 5. We'll keep this I. And then you have the whole array filled here. Then you have to total it. So we set the total to 0. We run the loop. Okay, now the only new thing here is, so previously we saw total is equal to total plus val. So the only new thing here would be that this value is not going to be a simple number anymore. Instead, it will be the value from the array that we have to use. So since we're talking about rating array, so we need to pick the value at index 1, which is 9.5, then 8.9, then 10. So in order to pick this value, I need to replace this val by the current value of my array. My array is currently called ratings, and the loop variable is j, so I need to make it j like this. So the first value picked would be 9.5, and it would be added to the total. Then the second value picked would be 8.9, and then it would be added to the total, so on and so forth. This is how it will work. And also you don't need to save this in a separate variable. You don't need to save the array value here, so you can directly use it like this. I'm just keeping it there because it's more familiar to all of you. So this is how you sum the array, and then you have to find the average, so you just divide it by the number of values. Then how do you find the maximum and minimum and output the array indices? Okay, so let's say you have this array, so you have to output what is the highest value. You can clearly see the highest rating is at index 3. This is the largest rating, and the smallest rating would be at index 5. So this is the smallest rating at min. And then we just don't need to output the values, we also need to tell where we found it. So we found max at index 3, and then we found min at index 5. So we should be able to output these 4 stats, max, min, and their indices. Okay, how do we do that? So the algorithm is pretty much the same. Since we have the values already saved in the array, we'll assume that the first value would be the maximum and the minimum, similar to what we did when we weren't using arrays. And then we start the loop, we get one value, we save it in num. Again, it's totally up to you. And then we do the same thing that we've done before. If number is greater than max, then number becomes the max. Else if number is less than minimum, then number becomes the minimum. Okay, now the second thing we need to do is we need to save the index as well. So we clearly know that this index is saved in the loop variable, which is j in our case. So j would initially be 1, then 2, then 3, then 4, then 5. So what we have to do is wherever we find the max value, we just need to save the value of j there. In our case, that would be 3, and then it would be 5, and initially it could be something else. So this is what we'll have to do in the code. We are saying if we find a value that is larger than max, then at that point save the value of j in max index. So this means when we started with 9.5, we went to 8.9, we found 10. 10 is greater than 9.5, so the max index should save 3 now, which is the value of j. So here you save 3 into max index, and then at the same time we were checking the minimum value is 8.9 less than 9.5. Yes, so your minimum index points to 2 now. Then 7.5 is smaller than 8.9, so the minimum index points to 4 now, so on and so forth. So we just have to save the value of the loop variable into a variable, another variable, and then we simply output it at the end, top rated show. So you'll find the top rated show at this array. So we're assuming that the arrays are storing details of the same item. So whatever the max index was, we saw that this was the maximum value at index 3. So if we print the name at index 3 of TV show, so we can get this Breaking Bad top rated show. And then we can also tell that it was found at max index. Max index was basically 3 that we saved whenever we found a value that was greater than max. So this is how we find the maximum and minimum questions. Okay, so let's say the question says now you have to only output the values at odd indices. The array is already initialized with 500 string values. Okay, so we don't need to care about the size of the array. We just need to write generic code so it works. And they're saying that you have to print the values at odd indices. So 1, 3, and 5. This should be outputted. So in order to do that, you can again use the modulus approach. You can start from 1, go all the way till 500, check if modulus of 2 is not equal to 1, or sorry, it's not equal to 0, or you can start from 1 and you can do step 2. So it will output the first value at TV show index 1, which in our case is Last of Us, and then next die, since the step is 2, so 2 plus 1 would go to 3. So then it will go to TV show 3, like this. Then it will go to 5, then 7, and so it will print all the values at these odd indices. So this is how you do it. I've already explained this one. Array ratings have been initialized with 100 values. Output the count of negative ratings and output the sum of average of all the values. So we only have to count the negative ratings and we have to sum and average all the values. Okay, so what we have to do is we're assuming that there could be some negative ratings and we have to count them for how many they are. So I can clearly see there are 2 negative ratings here. This would be outputted separately, and then I simply have to sum all these values together as well. So I set my total and negative count to 0. I run a loop 100 times. I get one value from my array at once. I check if it is less than 0. If it is negative, then I increment the counter by 1. And regardless of that, I just add that value into the total because I have to find the sum and average of all the values. And at the end, I just print that and I end the procedure. I call this procedure array stat. You can call it anything. There are no parameters needed. The question will usually tell you what parameters are needed. Otherwise, you can just decide it on your own. So declare total and negative count as integer, like this. Now the next thing that we'll be looking at is linear search. So the idea of linear search is very simple. Basically, you want to find an element and check if it is in the array or not. So let's say if I am looking for avatar, so avatar is not in the array, right? So I'll go to index 1, I'll compare the value, then 2, then 3, then 4, and then 5. So none of them are avatar, then that means that the show does not exist in the array. Similar to how you search items in your daily life in multiple boxes and multiple drawers, etc. So this is what we have to do. And we have to make sure that we iterate the whole array only once we have seen the whole array, and if we did not find the value, then we output that the value does not exist in the array, otherwise we keep looking. Okay, so this is the general algorithm. So what we do is we ask the user to input the target value, then we loop through the array until we either find the target or have iterated the whole array. And if the values match, then we save the index and we output the finding condition, and that's it. Okay, how does it work? So we'll implement it using a procedure. We are not using a function right now. So here the idea is that you have an array called scores. It has multiple values. So here, first of all, there are 2 conditions till when we'll stop searching. The one is that we find the element that we're looking for, and the other is that we have seen the whole array. So as I said, if we are looking for avatar, so we'll compare it with every one of them, not, 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 and then once we have seen the whole array, only then we can decide, okay, that this is not in the array. Or let's say I ended up finding it somewhere on my second index. Let's say I have avatar here. So since they both match, so now my loop will end here. I don't need to look at the further values. That's the idea. So my loop will run until I have found the element. So found is equal is a boolean value, so I can just write is equal to true, or I can just leave it like this. Or I becomes greater than 5. I is my loop variable that will go to each item. So 5 times. Okay, every time what I'm doing is, so initially I'm setting found to false. I'm assuming that I did not find the item that I was looking for. So I'm setting found to false like this. And then I get the first value in my current. from this code's array, and then I check is it equal to the target value. So target value I've passed in as a parameter. When I'll call it, so I'll pass the actual value target. Okay, is target equal to current value? So is, let's say we are looking for avatar. So is avatar equal to The Last of Us? No, that is not the case. So we end up and we go to the next index I plus 1. Okay, did we find the value? No. Is I greater than 5? Is 2 greater than 5? No. So we repeat and we now get the value at the second index. So the value at the second index is invincible, and then we check is it equal to the target value. So is invincible equal to avatar? Again, the answer is no. So we keep on checking, and eventually I would become more than 5 because it will check against 3, then 4, then 5, and then it will become 6. So that would mean that the value does not exist in the array. So if you set the found to false initially, and even after running the whole loop, it remained false, it never became true because we didn't find the value. So we can just output if found remained false outside the loop, we can output target was not found. So let's say if you did end up finding the value that you were looking for. So if you were looking for invincible, so initially found was false because they don't match, but now invincible will match with invincible. So now what we'll do is they match. I will save the value of my current index. So my I was currently at 2, and I'll save that in target index, and I set found to true. So I make found equal to true because this will be my loop condition now. And then I go at the end, I increment I plus 1, so I goes to 3 now. And then I check is I greater than 5? No. And is found equal to true? Yes, found became true here because we found the value that we were looking for. So the loop should end, and then you check was found equal to false? No, it was true. So you output target, which in our case is avatar. So this will say avatar found at index, and it was found at index 2. So this is going to be the output. This is how the linear search works. So it runs all the way until you find the element, or you have seen the whole array. Every time you compare the value, if you get the value, you save it. You save the variable, you save the index in a variable, and then you set the flag to true. You can use any other convention of your choice. With this, we are done with linear search. Now we move on to nested loops. So the idea of nested loop is a loop within a loop, and for each outer loop iteration, the inner loop will run completely. So let's say if currently we choose value of door as 1, so box will run from 1 to 5 for each door. So the value would change something like this. So let's say we have door and we have box here. So door is 1, and value of box will change from 1, 2, 3, 4, and 5. Then and only then, after next box, we go to next door. So door becomes 2, and then the inner loop restarts from 1 to 5. So this again goes from 1, 2, 3, 4, 5. Then again it goes to next box. So the box is complete, so we go to the next door. So door becomes 3 now, and again the box opens from 1, 2, 3, 4, 5. So this is the idea of a nested loop, a loop within a loop. Now we will be using this in order to, the applications of this would be iterating 2D arrays. So basically in bubble sort and iterating 2D arrays. All right, now we look at bubble sort. So the idea of bubble sort is that we have to sort the array in either in ascending order or descending order. So we need two loops here because we have to compare each value with each value. And if you just iterate the array once, it is not possible that your array can be sorted. You have to go through multiple times. So what do we do here is we have a procedure called bubble sort, and here we pass in the array that we want to sort, and then we declare sorted as a boolean, and we set it to false initially. All right, so let's say we are looking at this array which is clearly not sorted. So let's say 9, 8, then I have maybe 10, I have 7, and maybe I have 6 here, something like that. Okay, so I set sorted to false initially. To explain what bubble sort will do, essentially there is this video I've attached here as well. So you will go through each item and you will check if they're out of position. So 9 is out of position with 8, so you will swap them. Then 9 and 10 are in position, then 10 and 7 are out of position, so 7 and 10 would be swapped, and then 10 and 6 are out of position again, so 6 and 10 would be swapped. Now 10 is in right position, so you do not need to look at 10 next time. You do not need to look at index 5 next time. Then we repeat again, 8 and 9 are in correct position, then 9 and 7 are to be swapped, and then 9 and 6 would again be swapped. So now 9 is also in its correct position, so you do not need to look at 9 and 10 or index 4 and 5. So this will repeat again, and then eventually the array would become sorted. So we initially start with the assumption that the sorted is false, that the array is not sorted yet, and items are equal to 4. Okay, now why am I setting items to 4 when they clearly 5? The reason for that is that while we'll be going through this array, I'll be comparing the current value with the next one. So when I compare 1, I compare it with 2. So index 2 with 3, 3 with 4, and 4 with index 5, and then 5, it cannot be compared with any value after that. So if I go all the way till 5, then it will be, if I increment the value of index by 1, then it will be compared against an index 6 which does not exist. So that's the idea. That is why I will always keep it -1, so that at the second last item it only compares with the next item, and then there is no invalid comparison done after. So we start. Now we assume while sorted is not equal to true. This is just to run the loop initially. Okay, so this assumption written here is just to run the loop once, and then we now assume that the array is going to be sorted before we iterate the array. Okay, so here we are going to assume that the array would be sorted here, but you can clearly see it's not sorted as of now. Again, this was just an assumption to run the loop. This is where the mechanism starts from. Okay, so we have an inner loop now. The inner loop runs from 1 to number of items, which is 1 to 4, and then we check if the value of current index of rating is greater than the value of the next index of ratings. So again, comparing, is the value of 8 greater than 9, or is value of 9 greater than 7? So since this case is true, now you have to swap. Okay, in order to solve these values, you cannot just overwrite 7 with 9 like this, right? Or you cannot overwrite 9 here, because you have permanently lost the value. So what we do instead is, we'll save this value first in some variable, let's call it temp. Then we bring the second value over it, so it's overwritten, and then we retrieve the value that we saved and we go on to the next index. So 7 and 9 are in correct position now. You can imagine something like this, that you have to swap the materials of these two glasses. So you will bring in another glass and you'll exchange their contents, and that's it. Okay, so how do we do this? We get the value of the current index and we save that in a glass. You can call it anything. So the first step is, we get the value and we save that in a temp variable. Let's call it glass here as well. Okay, then in the next step, you are going to bring the value of the next index onto the current index. So the value of next index onto the current index. So 7 is also brought here. And then in the last step, you bring the value that you saved in the class onto the next index. So the value we saved in the class was 9, and we bring it onto the next index. So if you don't get this, you have to dry run this on a piece of paper with some array and with some values, and then it will make more sense. And then we set sorted to false, because we have made some sort of a swap. That means the array is not sorted like this. Okay, so let me sort the array a bit. 7, 8, 9, 10, and 6. Okay, so, and then we do items -1. So the reason for that is, so outside the loop, once we have seen the whole array once like this, I'm doing items -1 because at the end of every iteration we will definitely have one item sorted at the rightmost side. So initially at this point we would have sorted 10 here like this. So we don't need to look at 10, as I mentioned before. So maybe we can have 3 here like that. Okay, we start again. Now we check, is sorted not equal to true? No, sorted was equal to false last time. So we repeat the same process now. Is 7 out of index is out of position with 3? Yes, so you swap 7 and 3, you swap 6 and 7. Now it is sorted. Okay, so let's quickly do it for sorted and see how it will work. So item becomes -1. So now 9 is also sorted. So you don't need to look at 9. So now the loop iteration is also reducing. So it saves us time and space when we're running this algorithm in real life. Okay, we set sorted to true again. Okay, and then we check, is any value out of order? 3 is not out of order, 6 is neither, and 7 is neither, and we are not checking 9 and 10 because our loop will only run from 1 to 3. And since sorted remained true at all of these, that means when the loop ends, you do items -1, so that means 7 is also in its correct position, and you go all the way up and you check, while sorted is not equal to true, but sorted became true here, so that means the loop will end instantly, and then you will end while and end the procedure, and the array is fully sorted. That's the idea. Okay, so every time there is a swap, you set the sorted to false and you check it every time, is it still not equal to true, and once it becomes true, then you stop sorting the array. This is bubble sort in a 1D array. Okay, now let's talk about 2D arrays. So in 2D arrays, basically it's a sort of a matrix or a table which is used to represent data with multiple rows and multiple columns. So it's used to save images, tabular data, board games, matrices, etc. It is used to save images, bitmaps, tabular data. If you want to implement board games in programming like chess, like checkers, so for that you have to use 2D arrays, and then you have matrices, etc. So I'll be going through it swiftly because we have already done 1D arrays. So for 2D arrays, the declaration is kind of the same with a bit of a new thing. So you have declaration of name, then you write array, then you write the lower row to upper row, and then lower column to upper column. So you need to remember that the first index would always be row, and the second one would always be the column. So 2D arrays, if we were to visualize them, this is how it would look like. Okay, so there would be multiple rows and multiple columns. In my case, 5 rows and 2 columns. You can have of any different dimensions. So if I declare info of array type with 5 rows and 2 columns of type integer, so this is how it would look like, obviously without the values because it will be null initially, like this. Alright, so output the values in the whole 2D array. Okay, so let's say my whole 2D array is empty and I want to add some values in it. So for that, I need to run a nested loop. The reason is simple because I have to iterate either through rows or through columns one by one. So outer loop I can run from rows. This will read the each row one by one. So it will pick row 1 because row is in the outer loop and go to column 1 and then column 2. So for each row it will go to both columns, and then you can output the info at each row and column. So call this row would be 1, column would be 1, and the next time row would be 1 and column would be 2. So it will output this cell and this cell. Maybe here we have A and here we have B, so it will output A and B. Okay, and then let's say if you want to input the values, so you just change it to input here, and then if you want to read the values column by column, so maybe in this order, 1 2 3 4 5, and then 1 2 3 4 5. So for that you will run the loop from column 1 to 2 and row 1 to 5, but inside the 2D array you would always use the first index of the row, and then always you'll put the column. Okay, now how do we save values into the 2D array? Okay, let's say we have this 2D array now. So here we don't want to save data blindly. We know that we can save ID in first column and result in the second column because the question has told us so, or because you'll be given a hint of some sort. So these are labeled. Okay, so we have to save distinct items of data in both columns. So there's no need of going through each cell of each row and each column. Instead, what we can do is we can use a single loop, and we can ask the user to input the ID, which will save in column 1 and the result in column 2. So that is what will happen here. So instead of going to each column here now, we can just simply run a loop for all the 5 rows, and then student, so whatever the user enters into the ID, so that will be saved into the first column. Let's say ID is 005, like this, or 500, and then whatever the user enters as result will go into the second column. Maybe the result is 90, so that it goes here. Then row changes to 2, so we repeat the same thing for 5 times. So this will allow us to store the data properly under the proper column. Okay, so let's say you want to input the data into a certain column of the 2D array. So here you'll just run the loop for row number of times, and you'll keep the column number the same. So let's say the user will pass the column number as a parameter. So let's say column is 2, so this column is replaced by 2 here, and this column is also replaced by 2 here. So row 1 column 2, row 2 column 2, so like something like this: row 1 column 2, row 2 column 2, row 3 column 3, 4 and 5. So initialize all the values of 2D array to -1. We have already done this. We just run a nested loop and we assign all -1 to it. Okay, then how do we sum and average all values of a 2D array? Again, so I'm not going to go into depth. So we have the nested loop. We just simply add the value of total. So before we were using 1D array, it was a single index. Now it has 2 indices, so we simply add that. Now let's say the question says you have to sum a certain row here. So for a certain row, let's say you want to sum row 3. So that means the row number remains constant, and you just have to iterate through the columns, column 1 and column 2. So you will run a single loop for each column, and then you can have a total here, and then you can add the value of your 2D array. So the row number will be given as the parameter, or the user will input, let's say it's 5, and the column will change as loop variable. So this would be 5.1 and then 5.2. So this would be 5.1 and 5.2, like this. and the opposite of this would be applicable to sum the column. Then how do we find the maximum and minimum? So again, same thing, we have the nested loop. We set the initial value to max and we set the initial value to min, the first value of 2D array. And then if you have the maximum value here, so let's say 91 is the max here and 52 is the min here. So now you need to tell that this maximum 91 is at row 1 column 2 and this minimum is at row 3 column 2. That means you have to store them in two separate variables for each. That is what we have to do. We save the maximum value and we also save the current index of row in a variable and then current index of column in a variable. We do the same for min and then we can output as we've done before. Okay, then we have the 2D array linear search. So let's say you're looking for an item in this 2D array. So it depends if you have to search a certain column, a certain row, or the whole 2D array. For now, I'm going with the whole 2D array. So the same logic applies here. Let's say you're looking for maybe 81. So you found 81 at row 4 and column 2. This is what you have to output. So you run a nested loop. You check if the value is equal to the target value that you're looking for. If it is, then you save the value of row in a variable, value of column in a variable, and then you set the flag to true, whatever you're using, found, searched, etc. And then once the loop ends, once you have seen the whole 2D array, so you've seen the whole 2D array, only then you can decide if it was in the array or not. And then at the end you can check if found still remain false because it initially was false, and even after iterating the whole loop, if it still remained false, then that means that the target was not found. Otherwise, since the target was found, you can output row and column of the target is in rnum and cnum. This is where you save the values of rows and columns. So for 52, it will output row 3, column 2. This is linear 2D search. Then the next thing we have is bubble sorting in the 2D array. So in order to bubble sort in this 2D array, in the question you will always be told to sort on a certain column. Let's say you have to sort on this column result, column 2. So here what you have to do is if you swap these two values, so they are in order, let's say, or maybe we want to do ascending order, so this should be 88 and this should be 91. But there is a mistake that their IDs were not swapped. So you need to swap their IDs as well, otherwise the data will get corrupted. So this is the only difference between a 1D bubble sort and a 2D bubble sort. And in order to implement this, we'll use the same logic that we have done before. Instead here, what we'll do is that when we check if the value of the current row, column 2 value, is it greater than the value in the next row. So let's say current row 1 column 2 value, is it greater than row 2 column 2 value? If it is not, or if it is, so we are going for ascending order for now. So since they are out of order, so I will first swap the marks and then I will swap the ID, and that's it. So you can read the code on your own. Then the second last topic is ADTs. So I'll just walk through the pseudocode for this. So for records, this is how we use the pseudocode. You can create a type, and then inside the type of the record we can create multiple items of data, multiple features like name, rating, genre, and we have to define their types as well. And then to create a single record, so we'll create this variable and it will be of this type record, game in our case. And then if you want to assign properties, so you will say game1 dot, so whatever the record properties were, name, rating, and genre, so you can set them manually using the dot operator. And if you want to create an array of these records, so instead of saving them one by one, you can create an array, and then at each index of the array you can save multiple features of data. So you will have an entry of type game, which is a record in the index 0, and then index 1, and then index 2, and then all of them will have three properties that you can manage. Then stacks. So stacks are ADTs, which are essentially first in last out data structures. This is how they work. So every time you add a value, the top will move one by one up, and once you remove a value, it will move downwards. This is exactly how you put your books in a stack or plates in a stack. Whatever you keep at the first will be removed at the last. And then how is the stack implemented? We use a 1D array and we declare an integer for the stack pointer or the top, and then we have to have the push and pop routines and check if the stack is full or empty, etc. And we also have the number of stacks, which corresponds to the size of the required stack. So if you have a stack with size of 5, so you'll be keeping a track of number of items. This is all attempted using a 1D array. So as per the syllabus, you're not really required to know the pseudocode at this level, but it's a good idea if you just skim through this. So what we do is, in order to push a value onto the stack, what we do is wherever the value is stored, so let's say death note was stored, and then either the top would be pointing here or top would be pointing at index 1. So for in case if the stack is not full, if there is a space, so we'll increment the top by 1, and here we'll have a new value and we'll save it like this, and now top points here. So I'm going to save the item into the stack, which is my 1D array at the index of top pointer. So this is the index that we're looking at. And for pop, what we do is we check if there are no items in the array. And in order to check that, we can just check for the stack top pointer. Okay, so let's say this value isn't here and neither is this. So now top would be pointing at -1, or in our case it will be pointing at 0. So here you can check for 0 if you're starting from 0, otherwise it will be from -1. So you check if it is empty, and if it is not empty, then what we do is, let's say I want to remove Last of Us, so I'll pick this value, I'll save it in some variable so I can return it. So this goes into item, I save Last of Us in item. I can just override the value of Last of Us, and I don't necessarily have to delete it from the stack because it will be overwritten anyways, and then I can return the item. Okay, then we have queue. So queue is first in first out data structure. That means that whatever value joined the queue first will be removed first. This is exactly how queues work in our daily life when we are standing in a queue for waiting for your food or any sort of service. So how do queues work? So we declare a 1D array of a certain size. We have the front pointer or the head and the end, which is the tail. We initialize them. We have an empty queue initially, and then we have the size of queue, and then we have to also add some sort of functions like enqueue and dequeue. And then we can also check if there would be a wraparound mechanism that would be done in case of a linear in case of a circular queue. Okay, so what is a linear queue? Linear queue works in a very simple way. So this is our queue right now, and this is the current structure. So if we add any new show here, so now it will move the tail to the next one. And let's say if I want to remove any show from the queue, so it will be moved from the head. So this is the quick pseudocode for this. If there are number of items is already equal to 5, we are tracking the number of items. That means queue is full. Otherwise, in order to enqueue, we'll put the item at the tail and we'll increment the tail by 1. That is exactly what I did. And we increment the number of items by 1 as well. And in order to dequeue, we check if there are number of items equal to 0, like if there are no items in the queue. And if they are, so whatever is saved at the head of the queue, in our case it's invincible, we'll save it in the dequeue val, we'll increment the head by 1, so this moves one step further, and then number of items would be removed by 1. Again, as I said, you don't necessarily need to delete it because it will be overwritten eventually, and we can return the value. That's it. Then what if the queue is circular? So circular queue means that technically your head is pointing at Game of Thrones, and let's say I have multiple shows here. Let's say I have Brooklyn Nine-Nine and I have friends here, so the tail is eventually going to point here, and you can see there are two slots free here. So we cannot say that the queue is full just because the tail is pointing at the last index. So what I can do is I can check if there are slots available. So from index 5, I'll go all the way to index 1 and I'll point the tail of the queue here. So we can add more value like this. Okay, so we have maybe wire and then we have the breaking back. So now tail is pointing all the way here and the queue is full now. So this is the idea of circular queue. So what we do is, so if the queue is not full, we put the item on the current tail and then we wrap around using the mod function. So we take the modulus by 5. Basically, this is the size of the queue, whatever the size of the queue is, and then this would take us back to the start. Or if you don't want to use it, you can just check if tail is equal to the size is at the last index. Then you can just say tail would now be reset to 1 like this. Same thing, up to you however you want to do it. And for dequeue we do the same thing here. We check if there are no items in the queue, then we output queue is empty. Otherwise, whatever is saved at the head of the queue, we save that in another variable, and then we wrap around if there is enough space, and then we reduce the number of items by 1. Again, you can check here if at any point the head becomes equal to 5 or greater than 5, depending on the implementation, then head would be wrapped around to 1 like this. And with this we are done with queues. And lastly, we have the linked list. So linked list is a non-linear data structure. That means you do not know how the data is ordered. You will only be able to figure it out once you go from one node into another one. So this is how the linked list would look like. In our implementation, there would be two 1D arrays or one 2D array, and then you will have one column for data, one D array for data, and one for the next pointer. That means if you are at index 1, so it will now tell you where do you go next. And it says go to index, let's say 2, 3, 4, 5, 6, like this. So it says go to index 2 now. So I go to index 2, it says 13, go to index 3 now, so on and so forth. So for this, we will have a start pointer, we'll have a field list pointer, which will point to the next available node in the linked list. In our case, it is pointing at 4. This is where the next value would be inputted. And then we'll have some sort of index that will represent one node. So one node will contain data and the next pointer to it. This is how it is visualized. So we have the start pointer pointing towards the node, and then the node to the next one, and this is the phi operator, which means this is the end of linked list, which is often represented using -1 in the exams. And this is how we can visualize it. So the code of linked list is not tested again, but if that was the case, so you should be able to figure out the very basic code. So I'll get rid of this. So in order to initialize a linked list, what we do is we save -1s in all the data. So that is what I'm doing. I'm saving in the first column, I'm saving -1s, and then in the second column, I'm adding one value to the current value of x. So if x is 1, so I'm saving 2 in the next pointer, which makes sense because we are initially will go 1 from 2, then 2 to 3, then 3 to 4, 4 to 5, and the last one will save separately as -1 because this is going to be the end of linked list. And now let's say we have to output the linked list. Then what we do is we need to start from the start pointer, which is pointing to 1, and we output the value at the column 1 or column 0. In our case it is 1, and the next is at 2, like this. So then we say add linked list current pointer. So current pointer is at 1, go to its second column. So the second column is pointing to 2, and then this becomes your current pointer. So current pointer becomes 2 now, and then you check, is it equal to -1 yet? No. So you repeat the loop again. Is flag equal to true? While flag is true, yes. So then you output the value at the first column of this current pointer. So the first column is 13, you output that, and then you again go to the second column of the current pointer, which is pointing to 3, and then you go to that index, and then you keep on outputting the values, so on and so forth. So we're done with this. Now we'll move on to next topic and the last topic, which is file handling. Okay, so very easy topic. Why do we use files? We store it. We use them to store data permanently, create backups, retrieve data, share data to other users. We have multiple file modes like read, write, append. Read for reading the files, writing to create new file if it doesn't exist, and it also overwrites the existing contents of the file, and append to add contents at the end of the file. Okay, the following file modes are used. So read for reading, write for writing. I've already explained this. And then you'll also notice something like this, the end of file function, which is used to read the file till the end of file. So as long as it is true, that means that you have not reached the end of file. So for that we use while not end of the file, you keep on repeating something. Okay, how do we open the file? So in order to open the file, we use open file, file name for whatever the mode of the file processing will be. Then if you want to read a single line of the file, then we'll use read file, file name, followed by some string. Okay, so this has to be exactly the same. If you write read here, you will lose mark. If you write read the file, maybe, then again this is wrong. So it has to be read file exactly. So read file, the file name followed by some string variable. So whatever you'll read from the file will be saved in this single string. That's the idea. And when the command is executed, the next line of the file in the file is read and assigned to the variable. Similarly, if you want to write something to the file, so you will save that in a string variable, and that file and that will be written to the file just exactly like we did in the read file. So from read, in read file we'll be reading from one line of the file, and in write we'll be writing into the file one line at a time. So very simple question. Ask the user to input a game and write that to a file gamelist.txt. So for that we'll set gamelist.txt and we save that in a separate variable. We ask the user to input a game, whatever they input. Let's say they input FIFA. So what we have to do is we have to write that into our file. So we'll say open file f for write, then we will write file into this file gamelist, and we'll write gname. This is what the user inputted. Let's say FIFA. So FIFA is written into the file, and then we close the file. So let's imagine this is the file. Maybe this is the game list.txt. So this will only say FIFA like this. All right. Okay. Then read the contents of the line from the file song.txt and output it. Okay. So let's say there are some contents in the file song. So maybe it says, I don't know what to write or say, etc. Okay. All right, so you want to read this and you want to print this on the screen. So again, you will save the name of the file in a variable. You will open the file for read, and then you will write read file, this file followed by this content. This is again just a random name. You can name it anything you want. So this line will be copied and saved in content. And then when it will be printed, this is what it will say. It will say song name. I don't know what to write or say. And you always have to close the file as well. Otherwise you do not get marks. So this is done. And then now there could be questions that could use multiple concepts. So maybe read a line of the file song.txt and only output if it has more than 8 characters. So you read the file, you save that line into a variable, and then you can just apply the length function on that line, and if it is more than 8, then you output that content, otherwise you don't, and then at the end you close the file. Then maybe read a line of file and then count how many times a appears in it. Okay, let's say we have a file and we have some sort of a song here. Let's say we can go with, I'm just making the name on the go. Okay, we have this name, a fairy tale. So we want to count how many times a appears in it. So we have 1, then 2, and then 3. Okay, so how do we count this? Again, we will open the file in the read mode, then we'll read it into this line content. So since we have the line, this one line in content, now we just have to apply the string functionality here. So in order to count how many times a appears in it, we have to again separate it out using either the substring or the mid function, whatever is relevant to the syllabus. And then if we extract one character, so again we'll do it one by one. We'll use the loop variable, which will initially be 1, then 2, then 3, then 4, then 5, then 6. So I'll change it back, and then you check if character is equal to a. So it could also be substring content of I comma 1, and then if the character is equal to a, so we increment the count by 1, and then we end f, and then we output the frequency of that. So that's how to do it. Then copy the contents of the file movies into the watch list. So we are assuming that there could be multiple lines in this file. So we'll open the first file for reading and the second file for writing, which is watch list. And then I write while not end of file of file 1. That means as long as you have not read the file completely, you have not seen all the lines, you will read each line from the file, save it in content. So let's say the first line was the Dark Knight, and then you go into your file 2 and you write the Dark Knight in it like this, and then it will go and check again, is it not the end of file yet? No. So then it will read the next movie, maybe Joker, and then it will go and write Joker, so on and so forth. Then write the data from the file movies into an array my movies list. So very simple, we again run a loop from not end of file, we read the line into a variable called content, and then we save the value of content into this at the certain index I, and then we have to increment the value of I by 1, and we'll start it from 1, or you can start it from 0, up to you, and then at the end we close the file, and then copy the contents of movie list array with 10 elements into movies.txt. So we run the loop, we pick one value from the array simply as we've been doing before. So initially this will be index 1, then 2, then 3, then 4, then 5, and every time we are going to write the value of content into the file, and then we close the file. And with this we are done with the whole recap of our syllabus. If you have any queries, please let me know. That is all for this session. Thank you.